what the relationship is, the regression line. And the reason you call that an expression or a summarization of the relationship is you're looking at your scatter plot going, well, how can I really use this to figure out overall, this is just a sample of 89 people, but I want to judge overall, how does this relate IQ and GPA? So using the sample, we found this regression line, which probably comes through something like this. And so instead of trying to eyeball, well, if somebody has this IQ, most people have, these GPAs, which you can do that. There are intervals for that. Instead, we use the equation, and we say, well, if someone has an IQ of 106, we can predict what their GPA is. Okay, so this is what all universities in the country do with your SAT and ACT score and your GPA. When you apply to high-end colleges, they actually have more complicated equations and software where they take in consideration standardized test scores, GPAs, etc. to predict GPA. And the way in which they predict GPA is they don't really care necessarily about a number. They may. But they more care, is this person going to be successful here? Because if they're not, then we're not going to accept them. So this is the kind of thing that happens in that kind of decision making. That's why, actually, so how many, I don't know if anybody in here did, but you don't have to raise your hand. But if you had to take a compass score or math placement score, those score cutoffs are determined because there's an equation, some modeling that's been done to determine if this score is the placement test score, this is the predicted grade. And so if you're not going to be successful, you need to be placed in a lower class. This kind of stuff goes on all the time. Any questions about the actual calculations using the lines of prediction? Plugging in an IQ, getting a GPA, plugging in a GPA, getting an IQ. Okay. Then let's go on. When last time, I'm going to remind you as we go on, I'm going to remind you about ideas we talked about last time and how they relate to ideas we're going to talk about today. I'm going to draw just a few points on a scatter plot, and suppose the line comes through like this. I had told you last time that the way software determines the equation of the line is software calculates these vertical distances, and then if there's another proposed line, it calculates all those vertical distances, all of the vertical distances, squares them and adds them up. And whichever line has the smallest squared total is the best one. So if you're hearing this for the first time, this is what goes in under number 6. How do we find the equation that best fits the data, the concept? So this is what you hopefully have written somewhere in number 6. That the idea is that the line that has the smallest total squared vertical distance. So you find all these vertical distances, you square them, add them up. The line that has the smallest total is called the least squares regression line. Smallest total of the squares. Least squares. What I did not tell you last time is each of these vertical distances has a special name. It's called a residual. It's called a residual. Basically like a leftover piece or a little bit extra. So the idea is the line is telling you the relationship overall between the variables. But there are other things that factor in to make people different. So some people are above the line, some people are below the line. And the residual tells you above or below and by how much. So one thing of interest is to know how big these residuals are. It gives somewhat a measure of how widely scattered the points are around your line. So we're going to learn how to calculate a residual. So if we look at it this way, this is somebody with some IQ and some GPA. Let's say this is the 106 person. The person you a little bit earlier in your work had found for IQ of 106 what the predicted GPA was, right? So that means if IQ is 106, when you plugged it into the line, notice I'm drawing a dot on the line this time, When you plugged it in the line, what did you get? 7.149. So somebody with an IQ of 106, the line would predict their GPA as 7.149. But this vertical distance, since it's a vertical distance, depends on also knowing, well, what's the Y value you actually saw? This is a data point from your list of numbers. So let's look back at our data. Do you see anywhere in the data an IQ of 106 and their actual GPA? What is their actual GPA? 4. So the actual point that was in the scatter plot was 106, 4.0. Please ask me if you don't know what I'm talking about as far as a data point, an X and a Y from your data, versus the X and the Y that are on the line. Could I do this with any IQ? With any IQ in the list, could I see what GPA goes with it, and then could I plug in the IQ in the line and see what GPA is predicted? So for every single IQ in the list, you could find a predicted Y hat, which is the 7.149, and you can look up the observed Y, which in this case was 4.0. So this was just for an X of 106. Okay, so now in teams, I want you to fill in that point. For number 12, it says find the residual for the data point 106.4. 106.4.0. Again, that's what you fill in number 12, 106.4.0. And I want you to see if you can figure out how to find the residual. Brainstorm. How do you find a vertical distance on a graph? How do you find this distance when you know those?